Right. This video is going to talk about cost minimization. We've covered the isoquant and the isocost separately, but in graphing each of them, they use the same axes, labor and capital, for our two input model of the firm. Since they use the same axes, we can actually graph both of them on the same diagram. So we can do this. So what we're going to do here is, suppose that the firm, and the way we're going to approach this is to say, pick a level of output, a quantity that the firm's going to produce. And then we're going to say, what would be the least expensive way for the firm to produce this level of output? So we start here, I've just arbitrarily picked 100. So let's say that if the firm wanted to produce 100 units of output, how would they go about doing this? Well, we know we have isocosts, and we could draw those in here. And I will draw several in here now. And label them. And we're not going to vary the prices of labor or capital. So the slope of these isocosts will be the same. So I'm indicating that these lines are parallel. Now, let's consider some different points here. So effectively, the firm wants to produce 100 units of output, and they want to find the lowest cost way of doing that. Well, let's pick 3 different points here. At point A, the isoquant is steeper than the isocost. So clearly say, does point A minimize the cost of production? Well, no, because we know that isocosts that are farther to the northeast are more expensive. Those that are closer to the origin are less expensive. And so we can see that clearly, point A can't be minimizing cost, because the isoquant will, because it's steeper than the isocost, it's going to cut down here, and it'll necessarily get to isocosts that are a little bit closer to the origin. In fact, it's going to get down here to IC2. But you can see here that since the isoquant is steeper than the isocost, we can't be minimizing cost at a point like A. Then we come over to point C. Well, again, C is on IC3 as well. So in effect, we sort of already know it can't minimize cost, because IC3 is not going to be the minimum cost. But another way of thinking about it is that at point C, the isoquant is now flatter than the isocost. When the isoquant is flatter than the isocost, because it's flatter, it pushes in towards the origin a little bit more than IC3. And so we know it's got to be going to a lower cost isoquant than IC3. As we go to the left from C here, this isoquant has to be getting to a lower cost isocost than IC3. So that means point C can't minimize cost. What we said about that was true of any, the points we made about A and C are actually true about any point at which the isoquant is either steeper than the isocost, or the isoquant is flatter than the isocost. So by process of elimination, the only thing that's left would be a point where the isocost has the same slope as the isoquant, and that's point B, where they're tangent. You can't actually, because the isoquant comes in and it just happens to be tangent to the isocost at point B, it's neither steeper or flatter, so it doesn't actually cut any farther in toward the origin than IC2. IC2 is going to be the lowest cost cost that you can attain, that you can get on, given that the firm is going to produce 100 units of output. So tangency means that, of course, anytime two curves are tangent, we know that they have the same slope. So we have a tangency condition. And, well, we've already seen that the slope of the isoquant was the ratio of the marginal products. The slope of the isocost is the ratio of the input prices. So we get a tangency condition. that the ratio of the marginal products has to equal the ratio of the input prices. That's nice because that's true at point B, but it's not true at point A or point C or any other points on this Q equal 100 ISO quant. This equality occurs only at point B, which is the cost minimizing condition. So this literally would be if a firm had enough information to estimate their marginal products and then they could compare them to input prices. This gives you a way to, if you're running a business, to try to see if you actually are minimizing costs, because marginal products can be difficult to calculate, but because output is measurable and intangible, you can calculate marginal products in a way that you can't really calculate marginal utility. Utility is it doesn't. We don't have a unit of utility, so you can't really calculate a marginal utility. You can give you a problem where it's like, oh, Samantha's marginal utility of bananas is 6. We were just making up a number there. So I mean, we can make up numbers to talk about utility, but there's no unit of utility. There are units of output, and you could conceivably estimate this. And so this gives us, this actually, in addition to being something we get out of, or we get for a tangency condition to describe cost minimization, it's actually some usable, it's usable information for a business. If you can figure out marginal costs, you can compare them with the input prices and see how you're doing it in terms of minimizing costs. One thing I can say is the firm might want to try to get down to a lower cost ISO cost like IC1, but they can't do that and still produce 100 units of output. That they would run out of inputs and they wouldn't have enough to be able to produce 100. So the way we've set this up, we said that the firm is going to, if the firm wants to produce 100 units of output, they're going to operate at point B. And at point B, then the cost minimizing quantities of labor and capital would be L1 and Q1, or L1 and K1. They would be the cost minimizing quantities of labor and capital. This is what the firm should hire to produce 100 units of output in the cost minimizing fashion. So that's cost minimization.